Good morning. So I'm going to look at the hypothesis testing worksheet and look at the problem number 4 on the first page. Okay, so let's work through this one. You are the manager of a restaurant for a fast food franchise. Last month, the mean waiting time at the drive-through window for branches in your region, as measured from the time a customer places an order until the time the customer receives the order, was 3.7 minutes. You select a random sample. Okay, you select a random sample of 81 orders, so that 81 is going to be my N. Okay, from those 81 from those 81 orders, the sample mean waiting time is 3.49. So your X bar is going to be 3.49. Okay. And with a sample standard deviation of 0.9 minutes. So my sample standard deviation is 0.9 minutes. Okay, at the 0.10 level of significance, so that is going to be my alpha. So my alpha is going to be 0.10. Is there evidence that the population mean waiting time is different from 3.7 minutes? Okay, so the first thing that we're going to do is to label our null hypothesis and our alternative. Okay, so this last sentence says is different than 3.7. So I want to see if it's not equal, if it's something different than 3.7. So my null hypothesis is that it's going to be equal to 3.7. Okay, so right here, this tells me, this not equal to tells me that it's going to be a two-tailed test. Okay, so that's going to tell me that it's a two-tailed test. Okay, so that means that my significance level is going to have to be divided by 2. Okay, all right. So now, the next thing is to calculate your test statistic. Okay, that's the second part of the hypothesis testing. What type of test statistic would I be looking for here? I know my what over here. This is my key factor right here. I know my sample standard deviation, so I'm going to be looking up a t-score. Okay, so my first step is to do my null and alternative. So now I'm going to find my test statistic. So my test statistic is going to be to calculate a t-score. So remember, it's x bar minus your mean divided by the sample standard deviation, and that divided by your square root of n. So x bar would be your 3.49. Your mean is 3.7. And then your sample standard deviation is 0.9. And that is going to be divided by the square root of 81. Okay, so when you calculate this, you're going to get a t-score of a negative 2.1. Okay, so then my third step is to calculate your critical value. So we know we're at an alpha level of significance of 0.10. Okay, whoops, that's not very good. So alpha of a 0.10, but I'm going to be looking at a, what type of test here? A two-tailed test. So that means I need to divide my significance into two tails here. Okay, so I'm going to be looking up a 0.05. Okay, so inside each one of these tails is going to be the 0.05. So that is the value that you're going to look up in the tail. Okay, but we're looking at because we know our sample standard deviation, so we're going to be looking up a t-score in our table. So what you need to know is that 0.05 0.05, and you also need to know your degree of freedom. Remember, your degree of freedom is your n minus your 1. So 81 minus 1, which gives you your 80. So you're going to have to figure out where 0.05 and 80 intersect here in your t-table. So your value there is going to be 1.6641. 1.6641. So you've got two sides of it because it's a two-tail, so you're going to have a negative 1.6641 and you're going to have a positive 1.6641. Okay? Alright, so now is my decision. Now my fourth step is my decision. Okay, so my calculated t-score is a negative 2.1. Okay, so I'm going to redraw this little figure here. So we've got a negative 1.6641 and we've got a positive 1.6641. So where does my t-value of a negative 2.1 fall? Okay, it's going to fall somewhere in here, right? Because remember, that's an umbrella, and so this is going to be a negative 2.1 over here. So it falls in the rejection region. Okay, so my decision here is that I'm going to reject H naught, and that means that I'm going to accept H1, your alternative. So there is enough evidence to show that the mean wait time is different from 3.7 minutes. Okay, so there is enough evidence. Okay, we're going to do one more. This one's number 2. This one's on the back of the page, where at the top of it, it says more hypothesis testing. Okay, so we're on the back page looking at number 2. Okay, so number 2 says, in a recent year, it was reported that the mean wait for repairs for a phone company's customers was 36.7 hours. In an effort to improve the service, suppose that a new repair service process was developed. Okay, so I'm in a company and I have created a different process for hopefully to decrease this wait time, hopefully not increase this wait time. This new process used for a sample of 100 repairs. So my n is going to be equal to 100. Okay, I have a sample mean of those 100 repairs, okay, I found is going to be 35.3. Okay, the sample standard deviation is going to be 10.3. Alright, so is there evidence that the population mean amount is less than 36.7 hours? Okay, is there enough? Okay, so first step is to label your null hypothesis and your alternative. So your alternative is that is our mean less than 36.7 hours? Okay, and so that means that up here we're still going to have a equal to, or it could be greater than. Okay, so this less than right here is going to tell me that I'm going to have a one-tail test. And it's going to be a left tail. Okay. Alright, the second part is to calculate your test statistic. So from this information that we know, I know that I'm going to have to find, I know my sample standard deviation, so I'm going to have to find a t-score here. Okay, so I'm going to have 35.3 minus 36.7 divided by your standard deviation divided by the square root of your n. So your t-score here is going to be, what, a negative 1.35 5.92. Okay. Alright, so your third step is to find your critical value. So you know you want to have a level of significance of 0.01. Okay, so in that level of significance, we are looking at a one-tailed test, and it's going to be a left-tailed test. So that means over here is going to be your alpha, your level of significance. Okay, just in one of those tails. Okay, so we are looking at a t-test. So the critical value that I'm going to have to find is a t-score. So to find that t-score, I'm going to look up 0.01 and the degree of freedom of a 99. So I'm going to look up 99 and then 0.01. Okay, so that's going to be what? 2.3642. Okay. Now, it's going to be a left tail test, so that means that that value is actually going to be a negative over here. So it's going to be a negative 2.3642. So what's my decision here? My test statistic is a negative 1.3592. So where's that going to fall? So negative 1.3592 is going to be somewhere over here. Okay, so negative 1.3592 is in there. So that means that our decision is that we are going to, so the fourth step is we are going to fail to reject. H naught, and so that means that we are going to fail to accept H1. So even though that from those 100 repairs we had a sample mean that was less than our normal, okay, there's just not enough evidence to show that it's going to be less than, okay, 36.7 hours. All right, I will see y'all on Monday.